We now discuss the solution of a problem from the section Integral Calculus. This question is to evaluate the given definite integral. This question has appeared in the joint entrance examination main held on 26th June 2022 in the second shift. The given question is the integral 24 by pi multiplied by integral 0 to root 2 minus x square by, in the denominator, 2 plus x square multiplied by under the square root of 4 plus x to the power of 4 with respect to x is equal to. We have to evaluate this integral 24 by pi integral 0 to root 2. It's a definite integral and it's a quotient px by qx. Numerator is 2 minus x square by the denominator 2 plus x square multiplied by 4 plus x to the power of 4 with respect to x. That's the given question. We now discuss the solution of the problem in detail. Let I be the given integral, that is 24 by pi into I1, where I1 is the integral, definite integral, 0 to root 2, numerator by denominator. Numerator is 2 minus x square by 2 plus x square under the square root of 4 plus x to the power of 4 with respect to x. This is to be integrated between the limits 0 to root 2. Okay. Now, we take I1. Yes. In the numerator of the integrand, we have taken a x square common. When you take x square common, this becomes 2 by x square minus 1. In the denominator, from the factor 2 plus x square, an x is taken common, x times x plus 2 by x, yes, into under the square root of an x square is taken under the square root as a common factor. Then it will be x square into 4 by x square plus x square. And that x square from under the square root will come out as x. So that's what we have so far. So the common factors are cancelled. Integral 0 to root 2, numerator 2 by x square minus 1 by, in the denominator, two factors are there. The first factor is x plus 2 by x, and under the square root of 4 by x square plus x square is written as a perfect square, and then adjusted the terms. That is x plus 2 by x whole square. Then the 4 is added to make it a perfect square. Therefore, we have subtracted. Agreed. So the adjustment is all right. That's what we have done so far. That is the brought forward from the last slide. Now substitute x plus 2 by x as t. And in the denominator, x plus 2 by x is there. And under the square root also, there is x plus 2 by x whole square is there. And the derivative of x plus 2 by x is 1 minus 2 by x square with respect to x is equal to dt when you differentiate. Now this is a definite integral. So what happens to their limits? When x is equal to 0, 0 plus 2 by 0, that is it tends to infinity. T tends to infinity. When x is equal to root 2, it is root 2 plus 2 by root 2. That is root 2 plus root 2, that is 2 root 2. So when x is root 2, t is 2 root 2. Now this integral now becomes integral 0 becomes infinity, root 2 becomes 2 root 2, and this is 1 minus 2 by x square dx is dt. Here we have 2 by x square minus 1 dx, and that will be minus dt. That is why 1 minus has come out, dt. 1 by x plus 2 by x is t in the denominator under the square root of t square minus 4. So, I recall a formula, a ready-made integral is available. What is that? So, to call that ready-made integral, we have written this minus we have taken out, the limits are changed. Infinity to 2 root 2 now has become 2 root 2 to infinity, that minus is taken care of. 1 by t into under the square root of t square minus 2 square dx. Yes, now it is in the perfect form of the known integral. So what's that known integral? Recall. Integral 1 by x under the square root of x square minus a square dx is 1 by a secant inverse x by a. So here a is 2, it's not dx, it's dt. So it will be equal to 1 by 2 secant inverse 1 by a is 2, 1 by 2 secant inverse x by a, that is t by 2, to be evaluated between the limits t is equal to 2 root 2 to t is equal to infinity. For the upper limit 1 by 2 into, for the upper limit secant inverse of infinity minus for the lower limit secant inverse of 2 root 2 by 2. Now 1 by 2 secant inverse of infinity minus secant inverse of 2 to cancel, secant inverse of root 2. Now 1 by 2 into secant inverse of infinity is pi by 2, secant inverse of root 2 is pi by 4. 1 by 2 into pi by 2 minus pi by 4. Pi by 2 minus pi by 4 is pi by 4 into 1 by 2, that is pi by 8. So thus we have evaluated I1, but we have I is equal to 24 by pi I1. I is the given integral to be evaluated, and I1 we know pi by 8, 24 by pi into pi by 8. After cancellation we will get the answer 3. That is the answer to this question, and that is the detailed discussion of the solution of a problem from the integral calculus. And the question is to evaluate a given definite integral. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.